On the same day, NASA furloughed thousands of employees. A routine scan from the Perseverance rover exposed a faint but undeniable smudge exactly where 3i/Atlas was predicted to appear. The discovery confirmed the object's existence while triggering far more unsettling questions. The latest observations don't simply reveal something unusual about 3i/Atlas. They uncover an interstellar intruder with carbon dioxide-rich coma, perplexing water signals, a sun-facing halo, anomalous polarization readings, and most baffling of all, traces of nickel vapor with no accompanying iron signature. None of this matches the established playbook for comets or asteroids. Are we witnessing the emergence of a natural cosmic coincidence, or is something being deliberately concealed from view? The hard evidence demands closer examination, while high-resolution Mars orbiter images remained locked away behind institutional walls. Perseverance's navigation camera quietly captured a sequence that fundamentally changed the conversation. 20 consecutive frames, meticulously stacked by mission engineers, revealed a faint slanted smudge gliding across the Martian night sky, appearing exactly where 3i/Atlas was predicted to be. The alignment wasn't merely approximate. Using JPL's Horizons ephemeris system, the projected path sliced through identical pixel coordinates frame by frame, moving at the precise rate expected for an object hurtling past Mars at nearly 60 kilometers per second. This wasn't a cosmic ray strike, nor a stray satellite. The smudge didn't blink out or jump erratically between exposures. Instead, it traced a smooth, unwavering arc, matching the comet's predicted sky motion to within a fraction of a degree. The methodology was elegantly simple, yet remarkably powerful. Each image, taken mere seconds apart, was calibrated for the rover's exact location and camera orientation. When these 20 frames were digitally stacked, random noise faded into background while persistent features sharpened into clarity. What remained was a thin, elongated streak, barely rising above the noise threshold yet unmistakably real. The timing proved devastatingly precise. The imaging sequence began just as 3i/Atlas reached its closest approach to Mars, a narrow window calculated weeks in advance by mission planners. The probability of a random artifact appearing in the exact predicted location at the exact predicted moment across 20 separate exposures approaches statistical impossibility. No other surface asset on Mars reported a similar detection. The raw data, though not yet released to the public, has been quietly verified by multiple imaging specialists at JPL. Each specialist systematically checked for sensor defects, cosmic ray strikes, and atmospheric artifacts. None fit the profile. The only plausible explanation remaining is that Perseverance, through a combination of chance and meticulous planning, captured the interstellar visitor in action. This wasn't the detailed portrait that orbiters like HiRISE or Mars Express could potentially provide. The smudge remained too faint and distant for structural analysis. There was no visible tail, no discernible nucleus, no hint of active jets. But it represented direct photographic proof that 3i/Atlas existed at that location, moving exactly as predicted along a trajectory that no Martian satellite or known debris could possibly mimic. In a moment when official communication channels had gone conspicuously silent, the rover's 20-frame stack stood as the only real-time confirmation from the Martian surface. It served as a placeholder, evidence demanding follow-up, and a stark reminder how much more remained hidden within the embargoed data collected from orbit. For now, the Perseverance smudge represented the only solid anchor in a sea of uncertainty. It proved the object's reality while leaving every deeper question about its shape, composition, and origin dangling unanswered. Until the high-resolution orbiter images are released, this faint streak remains all that stands between speculation and verifiable fact. Across the solar system, a network of telescopes and spacecraft turned their sensors toward 3i/Atlas, each collecting a different piece of an increasingly perplexing puzzle. The James Webb Space Telescope, operating in the infrared spectrum, measured a coma dominated by carbon dioxide. The carbon dioxide to water ratio, based on Webb's NIR spectrograph data, came in at nearly 8-1, an order of magnitude higher than most solar system comets, where water vapor almost always dominates the volatile composition. Swift's ultraviolet telescope took a different observational approach, searching for familiar spectroscopic fingerprints of water and hydroxyl radicals. The expected ultraviolet emission lines, hydroxyl at 308 nanometers, water at 160 nanometers, registered as faint, barely distinguishable above background noise. Instead, Swift reported a stronger than anticipated signal in the carbon monoxide band, once again pointing to a volatile mixture that deviated significantly from typical cometary chemistry. Meanwhile, a polarimetry team using the Very Large Telescope's FIRS-2 instrument recorded a linear polarization measurement of minus 2.77% at a 7-degree phase angle. This wasn't merely a statistical outlier. It represented a fundamental departure from expected behavior. Most comets show positive polarization at these angles, and only a handful ever dip into negative territory, usually due to the presence of fine, highly reflective dust grains with unusual optical properties. What made the finding even stranger was the inversion angle, the point where polarization flips from negative to positive, which landed at just over 17 degrees. For comparison, classic comets typically hover near 21 degrees. The implication is clear. 3I/Atlas's coma contains dust grains with size distributions and compositional properties unlike anything previously cataloged in the cometary database. The Hubble Space Telescope, observing invisible light, captured a broad sun-facing halo that defies the textbook comet template. Instead of displaying a bright antisolar tail driven by solar wind pressure, the scattered light stretched toward the sun, forming an asymmetric fan-shaped structure. Theoretical models suggest this geometry could result from forward scattering by unusually compact or systematically aligned dust grains. However, the observed intensity and geometric configuration don't match any known comet in the extensive archives. The Very Large Telescope's UV spectrograph added yet another layer to mystery. In the gas phase spectrum, a distinctive line matching neutral nickel appeared repeatedly across multiple observations. But the iron emission line, expected to be stronger or at minimum comparable in intensity, was conspicuously absent. This discrepancy isn't a trivial detail. In every well-studied comet on record, iron outpaces nickel by at least a factor of 10 in emission strength. Here, nickel stands alone, isolated and inexplicable. Laboratory work strongly suggests that both elements should vaporize and photodissociate under solar ultraviolet radiation at nearly identical rates, making this chemical separation extraordinarily difficult to explain through standard thermal or photochemical processes. 5 observatories, 5 distinct anomalies. Each instrument independently confirms that 3I/Atlas doesn't merely look different in a single wavelength or from a single observational vantage point. The anomalies accumulate and reinforce one another. A carbon dioxide-dominated coma, suppressed water emission lines, negative polarization behavior, a sunward-facing halo, and isolated nickel emission without corresponding iron. No single comet in the modern observational record checks all these boxes simultaneously. The result transcends mere photographic mystery. It constitutes a multi-instrument puzzle that fundamentally challenges our working definition of what a comet can be. In late August, as professional telescopes scramble for a clearer observational picture of 3I/Atlas, a very different kind of investigation began circulating within private online forums. Remote viewing groups, including one coordinated by Bertie Jaworski, launched a series of blind sessions targeting an unnamed astronomical object. The coordinates and contextual information were deliberately withheld from participants until after the sessions concluded. Participants described, in strikingly similar terms, what they perceived as a thumb drive-sized device embedded within a much larger icy mass. Some mentioned detecting pulses or signals radiating outward, as the object was actively broadcasting information. Others spoke of intricate patterns or markings, what several participants characterized as graffiti, etched onto a smooth metallic surface hidden beneath accumulated layers of dust and ice. None of the viewers knew in advance what target they were supposed to be describing. These sessions took place before the Mars flyby, when only a handful of astronomers were even aware of 3I/Atlas's trajectory through the inner solar system. The descriptions, though vivid and internally consistent, remained entirely speculative, low confidence by any rigorous scientific standard. Even as official images stayed locked away behind institutional review processes, the narrative of a technological implant, something deliberately designed rather than merely drifting through space, started to blur the traditionally clear line between fringe speculation and public discourse. HiRISE, the Mars Reconnaissance Orbiter's flagship camera system, was perfectly positioned for a historic capture opportunity. The observational window was narrow, just a few hours as 3i/Atlas swept past Mars, close enough for orbiters to potentially resolve structural details that ground-based telescopes could only speculate about. Yet, as the flyby came and went, no images appeared in public channels. NASA's official media feeds, usually prompt to post new Martian vistas, offered only silence. The European Space Agency confirmed that its own Mars Express and Trace gas orbiter platforms had successfully observed the event, but withheld imagery, citing ongoing data review and calibration procedures. Raw telemetry continued to trickle through mission-critical operations channels, but the science-grade image frames, the ones that could definitively settle questions of shape, surface composition, and structural characteristics, remained locked securely behind institutional gates. The timing wasn't lost on anyone paying attention. With more than 15,000 NASA staff furloughed by the federal government shutdown, the agency's public communication pipelines had slowed to a barely perceptible crawl. Essential skeleton teams kept spacecraft operational and archived data safely stored, but the usual processing workflows and public release of high-resolution imagery fell by the wayside, deemed non-essential during the crisis. ESA, meanwhile, faced its own bureaucratic hurdles and coordination challenges, further delaying any coordinated international data release. For the global community of astronomers and space enthusiasts, the information blackout felt less like standard scientific caution and more like an impenetrable institutional wall. Rumors inevitably swirled that the images were being deliberately held back for deeper internal analysis, or worse, that something captured in the observational data was deemed too controversial for immediate public release. In the resulting information vacuum, unofficial channels rapidly took center stage. Amateur astronomy forums parsed every fragmentary hint from raw telemetry streams, while social media platforms filled with escalating speculation and mounting frustration. What should have been celebrated as a triumph of planetary science, a coordinated multi-orbiter, multi-angle portrait of an interstellar visitor, instead became a sobering case study in institutional vulnerability and communication breakdown. At the precise moment when the world needed clear, authoritative data most desperately, the systems designed to deliver that information faltered under bureaucratic and political pressure. Until the embargo eventually lifts, the story of 3i/Atlas will continue to be told through rumors, fragmentary leaks, and the faintest of Martian smudges. Stacking up the accumulated evidence, the 3i/Atlas case reads like a hand of cards no natural object should statistically be able to hold. Start with the first anomaly, a mass so substantial and dense that despite clearly visible outgassing activity, its trajectory barely budges from gravitational perturbations, behavior not observed in any comet of comparable size on record. Add to that a coma that shines brightest toward the sun rather than away from it, directly defying the textbook physical rules for comet tails shaped by solar wind and radiation pressure. Then comes the chemistry puzzle. Repeated spectroscopic detections of nickel vapor with no corresponding sign of iron emission, a pairing that laboratory studies indicate should be nearly impossible to separate under standard solar heating conditions. Polarization measurements, though still awaiting full peer-reviewed publication, reportedly show a sharp inversion occurring at a lower phase angle than almost any catalog comet on record, pointing definitively toward dust grains with optical properties unlike anything previously documented. The trajectory itself presents yet another statistical outlier. Instead of slicing through the solar system at a wild, hyperbolic angle typical of interstellar visitors, 3i/Atlas hugs the ecliptic plane, threading its way past Venus, Mars, and Jupiter in a sequential pattern that would be considered rare even for the most precisely calculated gravity assist mission profile. And as if that collection of anomalies weren't enough to strain credibility, the object's trajectory passes through a narrow band of sky historically associated with the 1977 WOW signal, the most famous unexplained radio burst ever recorded by SETI researchers. Each of these features in isolation might be reasonably dismissed as chance variation or an observational quirk. But combined, they stack the statistical odds overwhelmingly against pure coincidence. The probability of all 7 anomalies manifesting together in a single astronomical object is so vanishingly small that it demands explanation, whether that answer points toward a previously unknown category of interstellar visitor or something even less conventionally expected. The case of 3I/Atlas now stands as a benchmark example for how far nature, or perhaps design, can stretch our observational expectations and theoretical frameworks. October 29th marks perihelion for 3I/Atlas, its closest approach to the Sun at 1.4 astronomical units. This represents a crucial moment when theoretical predictions face their ultimate test. If the object behaves like a typical interstellar comet, the intense solar heating could trigger dramatic outgassing episodes or even cause catastrophic fragmentation. But if 3I/Atlas is something fundamentally stranger, this narrow window represents the optimal opportunity for the unexpected to manifest. Anomalous trajectory changes, unusual brightening patterns, or even signals that defy natural physical explanation. Trajectory monitoring is absolutely everything. On October 3rd, it swept just 29 million kilometers from Mars, a remarkably close encounter by planetary standards. From that point, it accelerates continuously, reaching peak velocity of 68 kilometers per second by late October. After perihelion passage, the object slips behind the Sun from Earth's perspective, hidden from ground-based observational eyes and accessible only to the most sensitive space-based instruments positioned at advantageous orbital positions. November brings a rare and potentially decisive opportunity. ESA's JUICE spacecraft, originally designed for detailed study of Jupiter's moons, will have a dedicated observing window from November 2nd through 25th. JUICE's sophisticated sensor suite is specifically tuned for detecting faint, fast-moving objects, and mission planners have deliberately set aside dedicated time for targeted scanning campaigns. If 3I/Atlas fragments shifts course unexpectedly or flares in unusual spectral bands, JUICE is optimally positioned to capture the event. These observations are scientifically critical, offering the only comprehensive observational coverage as the object climbs away from the Sun before eventually returning to accessibility in the pre-dawn morning sky. Early December represents the ephemeris verification phase. As 3I/Atlas emerges from solar conjunction, its observed position will be meticulously checked against mathematical predictions. Even a slight positional mismatch could hint at outbursts, structural splits, or unexplained course changes warranting immediate investigation. David Farnokia and the JPL trajectory team will be monitoring the data streams with extreme attention. December 19th brings a final checkpoint opportunity, 1.8 astronomical units from Earth, representing the last practical chance for ground-based telescope networks to capture high-resolution observational data before the object vanishes permanently into interstellar space. A photoshopped image of Michio Kaku grinning beside a glowing comet circulates rapidly across social platforms, accompanied by a fabricated quote about extraterrestrial probes. In Russia, state media outlets hint darkly at a Western cover-up, while meme accounts churn out endless edited versions of the Perseverance smudge, tagging them with #Harbinger. Panic and parody spiral together in a toxic mixture, fueled by the ongoing NASA shutdown and conspicuous absence of official high-resolution images. But as the rumor amplification engine runs dangerously hot, the scientific community mobilizes its response. The Vera Rubin Observatory, barely a year into full operations, triggers a global parallax measurement campaign. Dozens of amateur and professional telescope networks coordinate their efforts to triangulate 3I/Atlas's precise position as it reappears in December's pre-dawn sky. SETI researchers schedule a targeted recheck observation at 1,420 MHz, the classic hydrogen line frequency, aiming their phase array systems directly at the comet's mathematically predicted path through space. Online forums that once traded wild speculation now post side-by-side sky charts, systematically cross-checking every extraordinary claim against observable data. The chaos of viral misinformation collides directly with a determined surge of organized scientific verification, creating a race between myth-making and transparent measurement. October 6 brought an uncomfortably close call. Asteroid 2025 TF, measuring just 2 meters across, skimmed a mere 419 kilometers above Antarctica before astronomers even detected its existence. Its precise orbit remains uncertain, flagged with a condition code of 7 indicating significant observational uncertainty. On Mars, Perseverance scientists have detected intriguing leopard spots, organic-rich patches paired with redox-sensitive mineral assemblages in the bright Angel and Sapphire Canyon formations. These geological features may represent the strongest potential biosignatures yet discovered on the red planet. But ongoing political battles over Mars sample return mission funding threaten to stall further progress indefinitely. In Washington, a classified UAP hearing featured a striking video clip from Yemen, a glowing spherical object struck directly by a Hellfire missile that nonetheless continued flying without apparent damage. The Department of Defense maintained strict silence while multiple whistleblowers faced coordinated institutional pushback. Solar storms continue battering Earth's magnetosphere, with solar wind speeds topping 600 to 770 kilometers per second, driving G-level geomagnetic storm conditions and pushing auroral displays as far south as Colorado and Hungary. 3 green-tinted comets, C/2025 A6 Lemon, C/2025 R2 Swan, and C/2025 K1 Atlas, simultaneously light up the sky, with Lemon possibly reaching naked-eye visibility at magnitude 4. SpaceX's Starship Flight 11 wrapped its final version 2 test series, including Booster B-15's landing burn sequence and Ship 38's thermal protection tile stress trial. China's Tianwen 2 launched successfully on a decade-long dual-target sample return mission. Meanwhile, NASA faces devastating budget cuts. 15,000 staff members furloughed, with only 3,000 deemed essential personnel, placing multiple flagship missions at existential risk. The Perseverance rover's 20-frame image stack, showing a faint but persistent smudge at the predicted 3I/Atlas position, marked the beginning of this investigation, not its conclusion. Across 5 major observatories, researchers have documented a carbon dioxide-rich coma, a unique nickel-only gas phase signature, and polarization values that fundamentally diverge from established cometary behavior patterns. Yet no high-resolution Mars orbiter images have been released to public scrutiny, and key chemical findings remain locked in peer review processes. While the 7-item anomaly framework outlines an extraordinary set of challenges to conventional astrophysical explanations, definitive answers depend entirely on pending observational data from the European Space Agency's JUICE campaign and Earth-based reacquisition efforts in the coming weeks. Public speculation surged dramatically in the absence of official institutional updates, but international scientific teams are now actively coordinating parallax verification checks and targeted SETI observation campaigns. The fundamental facts remain unambiguous. 3I/Atlas exhibits measurable departures from all prior interstellar visitors on record, and its complete story hinges critically on images and spectroscopic data still either withheld behind institutional walls or actively processing through analysis pipelines. Until those data files become publicly accessible, the debate necessarily remains open, anchored by what we've already observed and haunted by what remains frustratingly unseen. The truth about 3I/Atlas awaits in embargoed files and forthcoming observations. What we know already challenges our understanding. What we're about to learn may change everything. As 3I/Atlas emerged from behind the sun, ESA's JUICE spacecraft locked its instruments onto the target. Mission Control in Darmstadt, Germany, initiated the pre-programmed observation sequence at 4:17 Universal Time Coordinated. What the spacecraft captured in the following 23 days would either settle the mystery or deepen it beyond recognition. The first anomaly appeared within hours. JUICE's MAGI's infrared spectrometer detected thermal signatures that made no physical sense, while the sunward side registered temperatures consistent with solar heating at $1.40. Localized cold spots appeared across the surface, regions maintaining temperatures 40 Kelvin lower than their surroundings despite identical solar exposure. Dr. Elena Vasquez, lead analyst of the JUICE imaging team, reviewed the data 3 times before alerting her supervisor. It's as if certain areas are being actively cooled, she noted in her preliminary report. No sublimation process we know can explain this temperature distribution. Ground-based observers have predicted that perihelion stress might fragment 3I/Atlas, as happened with interstellar visitor 2I/Borisov in 2020. Telescopes worldwide watch for the telltale brightening and debris trail that would signal breakup. Instead, something far stranger occurred. At 22:34 Universal Time Coordinated, the Atacama Large Millimeter Array detected a sharp spike in radio emissions at 1.42 gigahertz, the hydrogen line frequency, but modulated in a pattern lasting exactly 72 seconds. The signal repeated 3 times over a 6-hour period, each pulse identical to the last. SETI at home servers, processing the data through their pattern recognition algorithms, flagged the transmission with classification no one had seen before: non-random, structured, origin uncertain. Dr. Jill Tarter, veteran SETI researcher, was pulled from retirement to review the findings. Her assessment, delivered in a closed-door briefing to NASA leadership, contained a single devastating sentence: "This is either the most elaborate natural phenomenon we've ever encountered, or we need to fundamentally reconsider what we're looking at." At 3:47 a.m. Eastern Time, an anonymous account posted a 47-second video to an encrypted file-sharing platform. The footage, stamped with high-rise metadata and Mars Reconnaissance Orbiter telemetry markers, showed 3i/Atlas in unprecedented detail. The object wasn't a comet, not in any conventional sense. The nucleus appeared as an irregular ellipsoid approximately 340 meters long, but its surface exhibited geometric regularity that natural objects don't possess. Parallel grooves ran along its length, spaced with mathematical precision. One hemisphere showed a matte, light-absorbing finish. The other glinted with a metallic sheen. Most striking was the plume, what astronomers have been calling outgassing. The high-resolution frames revealed it wasn't gas and dust being expelled randomly. It formed a coherent cone, vectored precisely, adjusting its orientation as the object rotated. It looked disturbingly like a thrust. Within 2 hours, the video had been copied, downloaded, and spread across every astronomy forum and social media platform on Earth. ESA and NASA scrambled to verify its authenticity. By dawn, both agencies confirmed the metadata was genuine, though neither would officially comment on the content. The unofficial embargo had shattered. The question was no longer whether the images existed, but what they meant. David Farnokia's team at JPL Center for Near-Earth Object Studies noticed it first. 3i/Atlas wasn't following the predicted trajectory anymore. The deviation was small, just 0.03 degrees over 72 hours, but it was there consistent and accelerating. Natural outgassing created random perturbations. This was directional, controlled. Farnokia ran the numbers 6 different ways. Each calculation returned the same impossible conclusion. The object had adjusted its course by approximately 840 kilometers, altering its velocity vector by 12 meters per second. No comet does that. No asteroid can do that. At 2 p.m., Farnokia picked up his phone and called the director. "We have a problem," he said quietly. 3i/Atlas just performed a trajectory correction maneuver. The UN Security Council held an emergency closed session. The White House convened the National Security Council. In Geneva, the International Academy of Astronautics activated protocols that had existed only in theory since 1989. Publicly, governments maintained careful ambiguity. NASA Administrator Bill Nelson appeared on network television to caution against premature conclusions while confirming that anomalous observations warranted further investigation. Privately, the world's major space agencies coordinated an unprecedented response. Every available telescope was retasked. Deep Space Network antennas focused exclusively on 3i/Atlas. Radio observatories from Arecibo's replacement facility to the Square Kilometer Array listened with maximum sensitivity across every frequency band. China's Tiangong-2 spacecraft, freshly launched and still in Earth orbit, received new orders. Mission parameters changed overnight. The probe's decade-long journey to collect asteroid samples was scrapped. New destination: intercept trajectory with 3i/Atlas, departure window in 96 hours. At the Parkes Radio Telescope in Australia, the night shift operator, Sarah Chun, was monitoring routine data streams when the alarm triggered. The hydrogen line detector had spiked again, but this time the signal was stronger, more complex. It lasted 4 minutes and 17 seconds. Within the carrier wave, analysts detected nested patterns. repeating mathematical sequences, prime numbers arranged in spirals, what appeared to be three-dimensional coordinate data. Most unsettling was the finale. In the last 11 seconds of the transmission, embedded in the modulation, was an image. It showed Earth, not a photograph. Something rendered from data, showing our planet's position, orbital mechanics, and the positions of every major satellite in geocentric orbit. The image was date-stamped, December 19th, 2025, 1433 Universal Time Coordinated. The coordinates matched Earth's predicted position exactly. The timestamp was 26 days in the future, the exact moment 3i/Atlas would make its closest approach to Earth on its outbound trajectory. It was an appointment, a rendezvous point, a declaration of intent. The message was drafted through unprecedented international cooperation and transmitted simultaneously from 5 of Earth's most powerful radio telescopes. Simple, mathematical, undeniable, a sequence of prime numbers, images encoding basic physical constants, a representation of our solar system with Earth highlighted, and finally 3 symbols, a question mark, an open hand, a circle, the universal symbol for peace. The response came 17 hours later, not from 3i/Atlas, from a point in space 0 Australian dollars and 30 cents behind it, a point where no object had been detected before. The signal was brief, a 3-dimensional star map showing a trajectory that originated 37 light-years away, in the direction of constellation Reticulum. Below it, a simple mathematical expression that made astrophysicists' hands tremble. E equals mc squared. They knew Einstein's equation. They knew relativity. They were showing us they understood the fundamental architecture of our physics. And they were coming closer. Every functional telescope on Earth, and in orbit pointed toward the coordinates. News networks broadcast live feeds. In Times Square, the Tokyo Dome, Trafalgar Square, millions gathered to watch the skies. At 1433 Universal Time Coordinated, precisely as predicted, 3i/Atlas crossed 1 Australian dollar and 80 cents from Earth. At that exact moment, the object's outgassing intensified dramatically. The plume expanded, brightening until amateur astronomers could see it with binoculars, a brilliant point of light moving against the stars. Then, for exactly 90 seconds, the object pulsed. 5 times. Each pulse visible in optical wavelengths, radio, X-ray, and infrared simultaneously. A signal that could not be missed. A signal designed to be seen. Jade's instruments detected something else. 3 smaller objects, each roughly 20 meters across, separated from 3i/Atlas, and began independent trajectories, not breaking apart, deploying, like a ship launching probes. 2 of the objects adjusted course toward Mars. Mission data showed they would arrive in Martian orbit within 94 days. The third changed velocity and heading, accelerating toward Earth's orbital path. Projected arrival, 847 days. 3i/Atlas itself continued outbound, its modified trajectory now taking it toward Jupiter, where it would perform a gravity assist, something no natural object would do, before eventually departing the solar system. But it was leaving something behind. 3 emissaries, 3 unknowns, 3 guaranteed future encounters. Dr. Sarah Chin stood before the UN General Assembly, her voice steady despite the weight of what she was about to say. For decades, we asked if we were alone in the universe. As of November 23rd, we received our answer. We are not alone. And as of December 19th, we learned something equally profound. We have been noticed. The objects designated 3i/Atlas B and 3i/Atlas C will reach Mars orbit in March 2026. The object designated 3i/Atlas A will intersect Earth's orbital path in late 2027. We have approximately 880 days to prepare for first contact, not with a distant radio signal, but with physical visitors to our world. This is not an invasion scenario. The trajectory alterations, the mathematical communications, the precise timing, these are not the actions of a hostile force. They are the actions of explorers, scientists, ambassadors. They came from 37 light-years away. They traveled for centuries, perhaps millennia, to reach us. They observed us, learned our physics, studied our languages, and now they're asking permission to meet us. Humanity stands at a threshold. The question is no longer, are we alone? The question is, what happens next? She paused, looking out across the assembled representatives of 193 nations. I propose we answer with our best selves, not with fear or weapons, but with curiosity, courage, and welcome, because in 880 days, everything changes. In 880 days, humanity enters a universe that's been waiting for us. In 880 days, we finally go home to a cosmos where we were never truly alone. Outside in the cold December morning, 3I/Atlas was still visible through telescopes, a fading point of light climbing away from the sun. But now, people looked at it differently, not as a mystery or a threat, as a messenger, as a bridge, as the first chapter in a story that was only just beginning. The universe had reached out and touched humanity, and humanity, trembling with wonder and terror and hope, reached back. The Chinese spacecraft Tianwen-2, NASA's hastily repurposed Lucy probe, and ESA's Hera mission are all en route to intercept the three objects. International teams of linguists, mathematicians, physicists, biologists, and philosophers work around the clock preparing communication protocols. The Mars-bound objects have been designated Visitors M1 and M2. The Earth-bound object is simply called the Emissary. In 847 days, humanity will meet its neighbors. The wait begins.